Hello, good to see you again. Welcome to Block 2, Solving Problems with Multiplication and Division, Lesson 14. I'll share my screen. So, in your previous lesson, you learned how to solve lots and lots of problems involving finding area of triangles. In today's lesson, you're going to extend your learning to know how to solve problems using the area of trapezium. Okay, some people call it, trapezia is the plural for trapezium. Okay, uh, I would like you to help us grow our mission of providing high quality maths education to the global population of children who may not be able to have the financial resources to either hire a private teacher or have high quality maths education. So, to show us that favor, click on the like button, click on the subscribe button, share the video to those you think could benefit, and click on the notification bell so that when new videos are released, you will be notified. Thank you. Before we start, I would like you to do the trivial practice questions in 3 minutes. You could take 2 minutes. Should be done in 2 minutes, ideally. All right. Assuming you've paused the video and you've answered the questions, here are the answers. So for the first one, you were asked to work out the area of the parallelogram. So by now, I'm sure you haven't forgotten the formula we learned, which was area of a parallelogram is the base times the perpendicular height to that base. So we could say it's 4. We could use 4 as the base, but there is no perpendicular height to the 4. So we ignore that one. We're interested in the 10 because we know the perpendicular height to the base of 10. So in that case, the area is 10 times 3, which is 30 centimeters squared. Next, you are asked to find the pair of line segments that are perpendicular. Well, we can start to pick the odd one out, the one that is not perpendicular. We know this obviously is not because they are parallel lines. You can see the pair of arrows pointing in the same direction, and we can see the lines are parallel. Next one, these two, it may seem that this one is perpendicular, but we are not definitely told that it's perpendicular by the symbols we see. The symbol we see is the right angle symbol, which clearly tells us that this is the perpendicular line segments. So it's that one. Next, you're asked to work out 3 times, then 4 in open bracket plus 5 close bracket. Now, we know, applying our knowledge of bit maths, that we need to do the bracket first. So we add 4 to 5, that's 9. 9 times 3 is 27. Let's do our new learning for this lesson. If we have this trapezium, okay, we can see that it has a pair of parallel sides. So something I really want you to take note of is because sometimes students get confused when they see parallelogram and then they see a trapezium. So we know by now that parallelogram has 2 pairs of parallel sides. So sometimes you see it, okay, like that. So we know definitely that that is the parallelogram. So the clear difference between the parallelogram and the trapezium is that the trapezium has just a pair of parallel sides. So this pair of parallel sides. And the same is true even if the orientation of the parallelogram is changed. So even if it's turned upside down, left, right, whatever. So the pairs of parallel sides, it's always true that a trapezium has a pair of parallel sides. But another thing we must need to have is to have the perpendicular height. So the facts we need to find the area of any trapezium is we must know the pair of parallel sides and we must know the perpendicular height between those parallel sides. But before we start to talk about the area, let's discuss how the formula for the area came about. So imagine if we flip this over to put these two trapezia, so plural, okay, to put them together so that we form a parallelogram, okay. Now, we can see that if we were to extend the dimensions of the trapezium that we have flipped over to add to the other side to form a parallelogram, it becomes that. Now, we know that to find the area of this parallelogram, it has to be the base, which is A at B, to the perpendicular height, which is H. So the area of that parallelogram is going to be A at B times H, which is the perpendicular height. But that is not what we were asked to look for. We were asked to look for the area of the trapezium. But we've doubled the trapezium now. So if we want to get the actual area of the trapezium, we're going to have to halve our answer. We're going to have to halve the area of this parallelogram. So that is what gives us the formula for finding the area of a trapezium. So it is half of the sum of the parallel sides multiplied by the height, the perpendicular height between them. Now, it is helpful to remember this formula in words. That's how I used to remember it when I was, a kid. The formula for a trapezium, to find the area of a trapezium, is half the sum of the parallel sides times the perpendicular height. And that's how I want you to remember it. Half the sum of the parallel sides multiplied by the perpendicular height. Okay, now that we know the formula, let's start applying it. Here is our first example. Very quickly, if we see a question like this, then we can just write the formula out. You say, oh, okay, it's half the sum of the parallel sides. And the parallel sides can be any letter. It can be x plus y, it can be a plus b, it can be c plus d. It doesn't really matter. You choose the letter you use. But you just need to remember that the area for the trapezium is the sum of the parallel sides. You halve it and you multiply it by the height between them. Okay, the perpendicular height between them. So very quickly, we can just substitute. So I hope you know what that word means. We replace the letters with the numbers that they represent. So, all right, so that's 4 at 6. We halve it and we multiply by 2. So when we do that, our answer will be 10 centimeters squared. I want to mention that you're going to see different shapes, different forms of trapezium. So let me just mention it now. You would see some trapezium that look like this. So this side is straight, and then this side will be parallel like that, and then that one would be like that, okay? Then you could see some that look like this, and you could also see another trapezium that we call isosceles trapezium. What does that mean? It means that this side is of the same length as this side, and this angle is the same angle as that angle. So we call that an isosceles trapezium. I just think you should know about it because you're going to see different forms of trapezium as we go along. So here is this one. Here, if we're asked to find the area of the trapezium, again, we write the formula, half times the sum of the parallel sides, okay? Of course, it should be in brackets because we have to add the parallel sides first, then halve it before we multiply by height. And we can see clearly that we have to ignore the 7 because we don't need that information to calculate the area of the trapezium. We only need to know the parallel sides and the perpendicular heights between the parallel sides. So in this case, it's 12 add 15 multiplied by 6, which will give us 81 centimeter squared. All right. You have done some learning. So what have you learned so far? You have learned the formula for calculating the area of a trapezium. You add the parallel sides, you divide by 2. Remember, to times by half is the same thing as to divide by 2. So you add the parallel sides, you halve it, and you multiply that number by the perpendicular height. All right, here is question 1. Pause video and answer question 1 in 2 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. So here, they are composed, they are so the trapezium, they are combined to make a parallelogram of which has this area. Okay, we know a parallelogram is the base times the perpendicular height, and so the trapezium is half of the area. Okay, that was what I explained at the start of the lesson. All right, question 2. Pause the video and answer question 2 in 2 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. So here we're asked to, so Amy and Whitney are finding the area of this trapezium. Amy used the formula and Whitney split it into a rectangle and a triangle. So you're asked to use each person's method to find the area of the trapezium. And then which method do you prefer? I actually prefer using the formula because it's just one approach. Really quickly we'll get the same answer. Okay. So I'm sure you did it properly and then you got the same answer. Yeah. Okay, here is our example for the next segment of our lesson so that you can do some more practice questions. Now, here, this person has found the area of the trapezium, but there is a mistake somewhere. Can you spot it? All right, I'm sure you spotted the mistake here. Okay, so we can see that the parallel sides, the units are in centimeters, but the perpendicular height, the height we're using is in meters. So that is something really important you want to take note of in math. Sometimes when you're giving questions, be careful to look around because they may want to use that to test whether you are observant. Make sure the units you're working with are the same. All right, we cannot be multiplying a centimeter unit measure, unit measure with a meter unit measure. So it's either we convert these ones to meters before we use them here, or we convert this one to centimeter before we use it here. So if we decide to convert, it's 0.5 meter to centimeter, that will be 50. So if you don't know how 0.5 meter became 50 centimeter, refer to our lesson where we did metric unit conversion and watch that video and do the practice questions. When we do that, we'll see that our answer is actually 3,000 centimeters squared. All right, it's time for you to practice the other parts of the other questions in this segment of the lesson. So pause the video and answer question 3 in 5 minutes. Okay, assuming you've paused the video and you've answered question 3, here are the answers. So mark your work and celebrate your success. So by now, you should know we just add these, we have it, and we times by that. Add these, the parallel sides. You can see the parallel sides are, sometimes they're not obvious, but you can clearly see, visualize the parallel sides. Here it's obvious, okay? And this is the isosceles trapezium I was telling you about. You can see these sides are marked, so they're telling you that these sides are equal. So we add these, the perpendicular height is 5. We add these, we have it, and we multiply by 5. And here are the other ones. So mark your work and celebrate your success. Well done. And look at the other trapezium I told you about. And look at another form of trapezium. What is important is identifying the parallel sides, okay? And the perpendicular height between the parallel sides. You can see this form here. Okay. Pause the video and answer questions 4 and 5 in 3 minutes. Assuming you've paused the video and you've answered questions 4 and 5, here are the answers. So here you were asked the area of the trapezium is 20 centimeters squared. Find 3 possible pairs of values of A and B, okay? So we're just looking for pairs of values that after we've added them and we have them, when we multiply by 5, we're going to get 20. And these are the pairs of values, okay? You can see if you add these numbers and you have them, whatever you get, if you multiply by 5, you always get 20. Okay, here you're asked, these shapes have the same area. Work out the missing lengths. Okay, so we know that this one is a parallelogram. So to find the area of the parallelogram, we do the base times the perpendicular height. So very quickly, base times perpendicular height, which is 6 by 4, will be 24 centimeters squared. Now, this is a triangle, isn't it? So we know that to find the area of a triangle, we have to do half times the base times the height. So if we keep going, we'll have 24 is equal to half of, we don't know, we know the perpendicular height, we don't know the base. So half of the base times the 8. So half of 8 is 4. So it means if we rewrite this, this is going to be, let me write it here, 24 is equal to half of 4, so 4 times b. That's what it's going to be because half of 8 is 4. Now to get b, we'll have to do 24 divided by 4, which is 6. So b is 6. So 24 divided by 4 is 6. Now this one is the trapezium. So for this one, I want to do it here. So we know the area, so we'll set it out the way we write the formula. So 24 is equal to half. We know we're going to add these two. Okay, so we know one of them, 1.2, plus we don't know the other one. Let's call it, put a question mark there, we don't know it, times, okay, whatever we have, which is the perpendicular height between them, which is 12. So let's keep going. 24 will be equal to half of 12 is 6. So we have 6. We have something in brackets. So 1.2 plus something we don't know. Okay. Now, something we could do is we could say, well, let's divide. Okay, we'll keep the bracket the way it is. Okay, imagine this is a whole unit. We don't want to, disturb it yet. Okay, so if we divide by 6, we'll be left with 1.2 plus something we don't know, right? Now, I want you to think there are 2 ways we could do this. We could expand the bracket. I haven't taught you that yet, how to do bracket expansion. So we could expand the bracket And then when we finish, we're going to have, a number here. We'll have the question mark. And then when we finish, we'll subtract 24. We'll subtract whatever we get from 24. We don't want to do that. So let's do the one I think you will understand much quicker. So we divide by 6. So 24 divided by 6 is 4. So we now have 4 is equal to 1.2 plus question mark. Now to get question mark, we'll do 4. So I'll carry on here. 4 minus 1.2 will give us our answer, which is 2.8. Okay? So that's how we got our answer. All right. Pause the video and answer question 6 in 3 minutes. All right. Assuming you've paused the video and you've answered question 6, here are the answers. So for question 6, you're asked to work out the area of the hexagon. So you can see the hexagon has two trapezium put together, side by side, one flipped upside down. So to be able to find the area, I'll just discuss it, what you need to do. I'm not going to spend time because I don't want the video to be too long. So these are the parallel sides, okay? So you can see that the perpendicular height, so so that's 16 meters. That's 11, that side is 11. And let's see, just a minute. Okay, right. Okay, so what I notice here is this whole thing is 14, okay? From here to here is 9. So from here to here will be 5, yeah? So 9 plus 5 will be 14. So this bit here will be 5. So this bit here will be 5, okay? Because the whole lot is 14, and we can see that here is 9. So that bit there is 16 meters. So the whole lot is 16. And let's see a quicker way to do this. So the diagram is a bit, just a minute. Let's rub this off. Okay, so here, this is 14. So that base there is 14. And that there is 16. So the base here is 16. And that is 11. So the parallel sides will be, so we already know that this is 5 because from here to here is 9. The whole lot is 14. So here is 16 and there is 11. So we add these two. We have it and we multiply by 5. So that will be 11 add 16. That's 27. And then we'll multiply by 5. Okay, so we have that and then we'll multiply by 5. And then this one, we're going to, or you can multiply by 5 and then you can have it. So you have this one, half of 26 is 13. So 27 is 13.5. So you do 13.5 times 5. Okay, the perpendicular height between them. And then you do this one, 16 add 4.5. 16 add 4.5. You have it. And then you multiply by 9. Okay, when you finish this and you finish that, you add them, you get your answer. Okay, this one, in a trapezium, one parallel side is 3 times the length of the other. The perpendicular height is 1/4 of the length of the longest parallel side. The perpendicular height is 1.2 meters. Work out the area of the trapezium. So anytime you have a question like this, you need to sketch it out. Okay, so in a trapezium, one parallel side. So you have your trapezium. So let's just draw it out. So one parallel side is 3 times the length of the other. So let's imagine the length, we call it x. And then one of the other parallel sides is 3 times the other side. So that would be 3x. The perpendicular height is 1/4 of the length of the longest parallel sides. So the perpendicular height is 1/4 of the length of the longest side. So the length of the longest side is 3x. So 1/4 of this will mean this will be 3, 1/4 of 3x is 3/4 x. Okay? Because if it's 3x, 1/4 of it will be to divide by 4 and to times by 1. Yeah? So it's 3/4 x. Okay, now they say the perpendicular height is 1.2 meter. Okay? Work out the area of the trapezium. Okay, so the perpendicular height, if the perpendicular height is 1.2 meter, okay, it means this here, 3/4 x is equal to 1.2 meters. So it means we know 3/4 is 0.75. So 0.75 x is equal to 1.2 meter. So to get x, we need to do 1.2 divided by 0.75. Now, there's something I want to show you. So the 1.2, so whenever you have something like this, you could do it without a calculator, or there's another way to think about it. So 1.2 divided by 3/4, because that's what 7.5 means. Okay, this you can rewrite it. If you divide in, you can change it to a multiplication, but you have to flip this over. So this is the same thing as 1.2 times 4/3. Okay, now 3 can divide this to give you 0.4. Remember what we learned about doing decimal division. So we cannot divide the 1 by the 3. We shift it here. That's now 12. 12 divided by 3 is 4. So 0.4 times 4. Remember what we learned about decimal multiplication. Okay, 4 times 4 is 16, but we have 0.4, so we have to put our answer back in, is 1.6. So x is 1.6, okay, because that's what we've just worked out. You know, x, just a minute. So x is 1.6. So if this is 1.6, then this will be 3 times 1.6. So 1.6 times 3. 3 times that is 18. 8 carry 1. 3 times that is 3 plus the 1 we carried. So our answer will be 4.8. So this will be 4.8. So if this is 1.2, the perpendicular height, then we have enough information to find the area. So the area, so I'll let you finish this one by yourself, will be 1.6 plus 4.8. We're going to halve it, okay? And then we're going to multiply by 1.2. And that is what will be our area, okay? So work it out and you would see that that is what your answer will be. So 1.6 plus that, we have it, and then we times by 1.2. That brings us to the end of our lesson. So what have we learned so far? So we have learned that you can find the area of a trapezium by using the formula of looking for the parallel sides, you add them, and you add them, you halve it, or you divide by 2, and then you multiply by the perpendicular height between them. And we also looked at some really challenging questions of composite shapes, of word problems where you have to sketch the shape out, you have to sift the information out, and then solve the problem. So well done for sticking around and for working really hard. Until next time, look after yourself and bye-bye.